All right, so if you want to try and implement the priority queue class using what we've already learned about binary heaps, it's very, very similar. We just have to change the comparisons a tiny little bit. So make a class called priority queue. Basically, you could just rename your binary heap class, just copy it so you can, if you want to save the original, change it to priority queue. We're still keeping a list of values, and that's all we need structurally aside from all the methods. We just need to store the values. So that's unchanged really aside from the name. What is different though is we're not just storing numbers like we were in the past, where we stored numbers and we just used the values of the numbers and compared. We didn't have a class, we didn't have individual items that we were storing, or well, we had numbers, but we didn't have a secondary class like node, which we are going to with our priority queue, because now each element has a value, or each node has a value and a priority. Oops, did I spell that right? Yeah, I guess that is right. I mistakenly thought I spelled that wrong. Anyway, so we have this node class, and each node will look something like this. We have a value. It could be a string, it could be a number, it could be something else. It doesn't matter because we're not using the value to compare. We're only using the priority. So each node has a priority, and that's the value that we use when we actually construct and rearrange the heap. If something is inserted, we're going to compare its priority to the other element's priorities. Once we remove something from the top, we need to sync down, a new element to the correct spot. We're going to compare using its priority. Also, just for some variety here, we are going to implement a min binary heap rather than a max. We've done everything as a max. Often, as like in the case of a hospital, also with the way that Unix, the nice values work, a lower value is going to be served first. So in this case, priority 1 is the highest priority, 2 is a medium priority, 3 is a low priority. So in a hospital, at least some that I've been to, the most critical emergency things are like level 0, level 1, and the least critical are level 5 or something like that. Okay, so we have two classes now, a priority queue class and a node class. Each node has a value, which doesn't matter for what we're doing. We just need to initialize it, and a priority, and that's important. Okay, so here's how it should work. Write a min binary heap. So all that means, to make it a min heap, you're just going to need to change the comparisons a little bit. Where in the past, we were swapping things. If one thing was greater than something, we now swap if one thing is less than, or vice versa. Otherwise, it's the same idea. So each node has a value and a priority. Use the priority to build the heap. As something is inserted, compare the priority. As something is removed, compare the priority. Then two methods. Rather than an insert method and an extract max, we're going to reskin them as NQ and DQ. Honestly, the naming doesn't really matter, but what you do need to change in your code is that when you insert something, as I already mentioned, you compare the priority level. You don't compare the value of the element itself, you compare the priority. When you remove something, you're going to remove the root of the heap, the top level thing, which is the highest, technically the lowest number, but the highest priority. We remove that, and then we have to have, we swap it with the last element. We have it sync down or percolate down, compare using the priority. So that's our goal. Give it a shot. In the next video, I'm just going to take our code we've already written and alter it. So you won't have to watch me, reconstruct the entire heap over like half an hour of code. We'll just take what we've done and just turn it upside down a tiny bit to make it a priority queue.